Hello, this is Mrs. Pullen for AP Statistics, Unit 6, and in this video, I'm going to go over two problems from the Review Multiple Choice Question Review Sheet for Unit 6. Specifically, I'm going to go over question 2 and 4. The z-statistic for a test of HO p equals 0.4 versus HA p is greater than 0.4 is z equals 2.43. This test is, and we look at all the choices, and the choices are looking to see if the results are significant at various significant levels, specifically 0.01 or 0.05. And so in essence, what they're really asking us to do is find the p-value and then compare that to the alpha, the significance level. And see, we start making our bell curve. And from this null hypothesis, I know p is 0.4. And I know that the alternative is greater than 0.4, but they didn't give us a test statistic. So normally they give us some sort of test statistic, and we would be shading above and finding that p-value. But they didn't give us any of that evidence, that sample proportion. What they did give us is the z-statistic. So that's equivalent. In other words, they kind of jumped a step for us. They helped us out, and they calculated our test statistic. That would mean the mean equivalent to 0.4 is 0. And with that, we can go ahead and find our p-value. Normally, it would be p hat is greater than whatever sample proportion they gave us. But again, they saved us some time and they calculated our z to be 2.43. And so now you would just use your normal CDF. So we have to do this by hand. We can't enter the whole thing into the calculator like we normally do with the stat test. And we're going to the right since it's a right-tailed test. And when you enter that value into the calculator, I got earlier today 0.0075. And so I'm going to compare that p-value to various alpha levels. So here's my p-value of 0.0075, which is certainly less than 0.05, and it's also less than 0.01. And so that tells me that the test statistic means that the test is significant at both the 0.05 and 0.01 levels, because both of those values are less than. So we would reject our HO and we would say that our results are significant. So now we're going to go on to 4, which is similar but not the same. The z-statistic for a test HO, p equals 0.4 versus HA, p, this should say not equal, so correct your paper, is z equals 1.73. This test is, and again, like the other problem, they're looking for us to determine if our results are significant or not significant. And so in order to do that, we need our p-value. This problem is a little bit different than number 2. Yeah, they don't give us our p hat, and they give us our test statistic. But how this problem is different, aside from having a different test statistic, it's two-tailed. So that means you have this like phantom z-score of the opposite sign. And you have to find the p-value to the left side as well. In essence, what you're just doing is you're just taking the area under the curve from one side and just doubling it. So the p-value is going to be twice the probability. And although you could do less than, I normally take the larger one. Z is greater than 1.73. So that's the same thing as 2 times normal CDF. The low is 1.73. The high is 9E999. The mean is 0, and the standard deviation is 1. And if you enter 2 times that value in the calculator, that's going to be 2 times 0.0418, which is 0.0836. And that value is greater than 0.05, and it's also greater than 0.01. So at both significance levels, you're failing to reject. And so it's not significant at either of those letters. I hope this video was helpful, and I'll see you tomorrow.